Welcome back to the Mechanics of Solids lecture series. We're working on torsion in indeterminate shafts and thin-walled tubes. Here we have one final example related to a thin-walled tube. This is a problem from Mechanics of Materials by Timothy Philpott, Wiley 3rd edition. The problem reads, a torque of T equals 150 kip inches will be applied to the hollow thin-walled aluminum alloy section, and the section geometry is shown in this figure here. If the maximum shear stress must be limited to 10 ksi, determine the minimum thickness required for the section. And we can assume all dimensions to be centerline or midline dimensions. So let's summarize what we know. Everything is summarized pretty well in this figure. We are also given that the torque should be 150 kip inches. Okay? We are asked to find the thickness T so that tau is less than or equal to 10 ksi. We can use the approximation for a thin-walled section that tau is equal to the torque divided by 2 times the area to the midline times the thickness. Rearranging to solve for T, T is equal to the torque divided by tau. In this case, we'll use the tau allowable times 2 times a sub m. Everything is known except for our area to the midline. So let's go ahead and compute that. Area to the midline equals. Now notice as I look here at this section, I can break it up into two pieces. The ends, which form a circle, I'll call those ends, and then the middle, which is basically a rectangle of 6 inches by 8 inches. Our circle has a radius of 3 inches. So the area of the circular part is pi times 3 inches squared. This is the ends, if you will, plus the area of the middle part, which is the rectangle, 8 inches times 6 inches. That's the area of the rectangle. And now those together compute to 76.26 inches squared. Now we have everything we need. T is equal to the torque, 150 kip inches, divided by the allowable shear stress, 10 ksi, times 2 times the area to the midline, 76.26 inches squared. Let's do a quick units check. Our kips here cancel out. We have inches per square inches on the bottom, which comes up to the top. So we have inches cubed on the top. We have inches squared on the bottom. Actually, these two cancel out. And so we're left with units of inches, and this computes to about 0.1 inches. This is the minimum required thickness for the section. This is a rather small number, but based on a sanity check for a thin-walled section, it's much less than the dimensions of the section itself. So it seems reasonable, and that concludes this problem.